Our next session will be a hands-on session on flow simulation. Our team member, Mr. Abhushan, is there. He will take the session.
Yeah, good morning, everyone. That was a nice session from Professor Manasuddha. So we not only we learn the theory, we also learn how to implement it in OpenFOAM. Now let's do a hands-on session where we simulate a laminar flow through a pipe. So I'm going to provide the link of our spoken tutorial for that, and I'm pasting it in the chat box. So we are using the same case that we did yesterday, the pipe. If you remember at the very end, we created a 3D pipe geometry. So you have to go to the same directory and then follow this tutorial. And you can download the files, code files that is required for this tutorial by clicking on the code files in the same website. So you can start your tutorial.
Sir, in my cavity file, pipe is not, folder pipe is not there, sir.
The folder pipe was created yesterday when you were doing the last hands-on tutorial. If you have, so if you, so if you have not done that, no problem. I will just provide the files in my drive. You can download it from there and then copy it to your WSL directory. Okay.
Okay, sir.
So I have provided a new link that contains pipe folder in case you don't have that, everyone.
Sir, after entering the command formation, this CD form run, that thing is a directory and
that, sorry?
Dash. Sir, I will share this thing.
Okay, you can share it.
Sir, after entering this command, it's showing me these things.
Okay, why are you putting dollar in front of CD?
Okay, sir.
I think you don't need to do that. That dollar is part of the CMD. Yeah.
Yes.
Now it works, right? Okay.
Yes, sir.
Hello, sir. Excuse me.
Yes.
Sir, I have empty transport properties file.
You have empty transport properties file.
Yeah, there is nothing in the file.
So that means either you have typed the spelling mistake. So you just created a new transport properties for your file. Just take, you can close that file and open a new one. Just make sure that the spelling are right.
Okay, yeah, okay.
Hello.
Yes.
Yeah, there's no such file or directory. After clicking move folder.
Yeah. You're in pipe, and can you do ls?
Yes.
So you have to go inside cavity, I think. What you can do is you can call MB and change the name of cavity to pipe and then use that. Can you do that?
Yes, sir.
MB cavity space pipe.
Hi, Bhushan, I am Joseph here. Actually, what is in control tech? Purge right? What is that? What is that doing?
Sorry.
That purge in control tech file one after right interval purge right is there, no?
Yeah.
Giving it as
that is in case you want to save space. So what happens is when you do control take and it will generate files for these time steps, right? So let's say your DT is 1 second, then it will generate 0, 1, 2, 3 until your final time step, let's say 100. So say you want to save space and you have make purge right 1 or 2. So what it does is first it will create a file 1, then 2. Now when creating the file 3, it will create the file 3, but it will erase the file 1. So there will be always only 2 time step file.
Oh, okay. It will keep only 2. Old files it keep on deleting.
Yeah, it keeps on deleting the previous time step file. But if you want to disable it, you have to keep it 0. So if it is 0, it is switched off. Okay.
Suppose if you keep 10, it will keep only 10 time steps.
Yeah.
Latest.
Yeah. Yes.
Okay. Thank you.
Welcome.
Hello, sir.
Yes, Calvin.
Hello. Yeah, so I'm again I checked the spellings. Again I'm getting the empty
Okay, you
transport
can
properties
save the
file.
screen.
Okay, 1 minute. Is it visible?
Yeah, it is visible. You can close this thing.
Yeah.
So you are in your pipe directory,
Yeah.
and can you do ls constant, ls space constant? So I think you are using a different version of OpenFOAM.
Yeah, OpenFOAM 10. Yeah,
So
version
in
10.
OpenFOAM 10, the transport properties has been renamed to physical properties.
Okay.
So you have to do get it constant space physical properties. Okay.
Yeah. Okay.
Yes, what is this?
I'm Madhura, sir. In the transportation properties file, Nussel number values are not there in the node file. Is there any problem?
Yes.
Wait, you can present the screen after this.
This is the file, right?
Yes, yes, Calvin, this is the file.
Yeah.
Yeah,
Thank you, sir.
welcome. Okay, Madhava, you can present your screen. Yeah, I'm able to. Yeah, there is it is there 1e minus 06. It's just that the dimension is not given. It's okay.
Okay. Fine.
Yeah, welcome.
Hello, sir.
Yes, Durul.
If I want to run the simulation steady state mode, like, which solver to use? Open
So if you want to solve steady state, you can use simple form.
simple form,
Yeah,
and we have to change the FP scheme or
yeah, you have to change every schemes and every solution for that.
okay.
So instead of like manually changing it, you can copy one of the case from simple form tutorial, and then just replace the block mesh and your U file and P file, and then you can carry out the simulation.
Okay. Or we have to if you want to save the mesh file, is there any way?
Sorry, I didn't get
The,
your question.
if I run the command block mesh, it's where this mesh is saved.
Oh, where it is saved. Okay. So in your constant, after meshing, you will find another folder inside the constant called polymesh,
Okay.
which is where the information of all those mesh is saved.
So
You can look into it. You can
that
go.
mesh we
Yeah.
can use for another case if you want to use.
Yeah.
Okay.
You can use that mesh for another case, but instead of copying the constant file, what we do is we just copy the block mesh file and then do a new mesh. That way you don't have to copy all those files.
Okay. Thank you.
Okay. So people who have completed the tutorial, can they raise their hand?
Bhushan, this block mesh we need to copy from yesterday's pipe file.
Yes, yes.
Okay, fine.
Hi,
Yes,
Abhishan.
yes.
I'm getting an input-output error. Like I just copy the U file, but it's saying there's an input-output error.
Can you show the error? Present your screen.
1 second.
So in your U file, I think you missed something.
Yeah, I just checked, but there is nothing missed here. See if
So
you
can
can
you,
see.
yeah.
This is my U
There's
file.
an internal field that is missing in your U file. So what you can do is type internal
I just
field.
copied it from.
Yeah, you copy it, but while copying, I think you copied on, I overrode those that in internal field line.
Okay, where
So
is it?
that would be just before the boundary field.
Okay.
Yeah. Here you can type internal field, like press enter and then one with capital F. Then tab. Press tab.
Tab.
Yeah.
Tab.
Yes. Tab. One more tab.
Okay.
And then uniform. And then space bracket. Then 3 zeros, just like how it is done in value there. And then close the bracket and a semicolon. Now save it. Now see if it works or not.
Yeah.
Yeah, welcome. So people who have completed the tutorial can raise their hand. I'm only seeing few hand raises.
I think Siddhi Vinayak wants to share his screen and share his problem.
So Siddhi Vinayak, I see that you have finished the tutorial, but you are not able to view the result. So you can follow the procedure that I mentioned yesterday. That is, first you have to do dots space result.form. Are you getting it, Siddhivinayak? Oh, your mic, is it not working? Never mind. I'll show you to you how to do it. Okay. Yes, Siddhivinayak, you are able to use Paraform as well. I think Siddhivinayak, you need to copy the blockmesh file into your blockmesh. So I think you missed that step, so that's why you are getting the square cavity. So what you can do is you can copy the files that was provided to you in the drive. If you go to chat, scroll up, you will find a drive link. From here, you can copy the blockmesh file and do the blockmesh again. Okay. Yes.
Hello, sir.
Who is this?
Sir, this is Madhav.
Okay, yes, Madhav.
Sir, it is showing cannot find file points in directory volume. Can I share my screen?
Yes.
Hi, I'm Joseph. Actually, we need to run blockmesh and ecoform, right?
Yes, you're right.
Okay.
Sir, can you see my screen?
Yes, Madhav.
Here, it is showing cannot find the file points in directory.
So I think you have not done blockmesh. So you need to do blockmesh. So we are a bit late actually. So I'm gonna just show you guys how to do it. Just follow me. I'm gonna present my screen. So this is a pipe case that was done yesterday. So if you do LF system, it has the blockmesh dict file that was used to make 3D pipe geometry yesterday. In case you don't have this file, I have shared a link of drive. I will say it again in the chat box. You can just use that. Now I have already downloaded the required files, which are these files. So what I'm gonna do is, so all I have to do is just copy the pressure and velocity and then control it. So I'm going to do ls and I'm going to rename my 0.4 folder to 0. And as you can see, the folder is renamed. And I'm going to go inside my 0. Here you can find U and P, U for velocity, P for pressure. So I'll open my U. And here I'm gonna copy paste this line. Okay. Oh, okay. I mistakenly copied. I'm going to save it. Again, I'm going to copy the pressure. I pasted the P file as well. Now, now I'm going to move back to my case. So from 0, I move back to pipe using cd space dot command. So I'm gonna copy paste that here. I'm gonna save it. So I'm gonna do block mesh, then IcoFoam. Okay. I've got an error that says ring file U and it cannot find paths for inlet. So let me see what is the issue. Inlet, outlet.
Sir, two boundary failed.
Yeah.
2 times boundary
There are
failed is there.
Okay, 2 times boundary field. Yeah. Okay, it ran. Current number is maximum. I think I made mistake while copying the file. It's okay. I'm just gonna download it again here.
Actually, my simulation is stopping at 0.08 time.
Yeah. So let me just
This file only we have used actually.
Yeah.
But there is no congruent number. Things.
It's okay. It's a pipe symmetry. Now go home. It just means that somewhere I may have given a very high velocity. Did you guys get the same error?
Yeah, I also got the same error.
Okay. So it just means that you have given a very high velocity. So what I will do is I'll just lower the value of velocity. Or do we need to change the value of so in
Sir,
property,
can we refine the mesh in this case?
Yeah, you can refine the mesh. Just a minute. I think I forgot one step. So here you have to change this to 1e minus 6, right? Okay. Yeah, this is the step I forgot. Now I'm going to save it and I'm going to run IcoFoam again. Okay, this time it worked. So let it run for a while.
Sir, in OpenFOAM, in every time step, we are getting some error like continuity error. Is it warning or some kind of error?
Does it say warning? So you do get a continuity error, but its value must be very low, right?
Sir, in this simulation also, we are able to see time step continuity error. So how to get rid of this kind of error?
So since this is an approximate solution, you'll get some continuity error. I'm going to be talking about that in the next session. So it's just that that value needs to be very low. As you can see, it's in the order of 10 to the power minus 10, right? Minus 6, 10 to the power minus 10, or 10 to the power
minus 6 and 5. Yes,
yeah.
Sir.
So it's just that it is there, but it is very low. So if it is very low, then it is fine. It's okay. We can view the mesh even while this thing is running. So I'm going to do that. I'm going to go to run and cd pipe and so I'm going to click on apply. So this is my pipe geometry. And if I do surface with edges, you can see the geometry, right? And I don't want to see the geometry. I want to see my results. So let the simulation complete. Okay, it has completed. I'm going to close it and I'm going to do touch result.home. And open it. I'm going to click on apply and then view the velocity. So in order to view the velocity, so what we have to do is we have to slice it or clip it. I'm going to clip it. So you can see the velocity profile when I clip it. And I'm going to go to the final time step. This is the pressure profile and this is the velocity profile. So it is a parabolic profile. So to see whether the profile is parabolic or not, you can use plot over line. Someone was asking this question in the chat, how to actually view it. So when I click on Y and if I click on apply, it will show me the profile. So this is the U profile, and as you can see, it is parabolic. So if you have any question, just type on the chat. Binayak will answer those questions. Since we are running out of time, so let's get on with the next session.
Sir, I could not complete this simulation. You have sent the drive file and I am using that drive file, but I could not complete the, it is showing some error in terminal.
So it's okay. You can say that either in the chat box. Binayak will try to remove your issues. But meanwhile, we have to go with another tutorial since we are running out of time. So you focus in for the next session. And if you have doubt, you can also send that either as a mail to us. We'll try to clear it. Okay.
Okay. Okay.
So the next, this hands-on session is going to be on residual and convergence and how we can control the residuals in OpenFOAM. So whenever you run any solver like SimpleFOAM, IcoFOAM that you will do, you'll get some bunch of log, right? So in that log, you'll see some residuals, initial and final residuals. Let's see what are they and how what does it tells us. So residual is actually the measure of imbalance of conserved variables. So whenever you are doing the simulation, you are solving some conservation equation. That could be momentum conservation or mass conservation or just temperature, energy conservation. That could be anything. So during the first lecture, you got general idea of what is CFD. So in CFD, you divide your domain into a bunch of control volume, and this is one of that control volume. So in control volume, you get some flux in and you get some flux out. So these are those in and out. And on top of that, if something is being generated, let's say if there is a heat source, if there is a momentum source, then something is also being generated, and the gen is that generation. In reality, the whatever is going out must be equal to the whatever is coming in and whatever is being generated. And if you subtract out minus in minus then, you should get a 0. But numerically, when you do a numerical solution or when you do simulation, those are approximate solution. So you will never get a value that is equal to 0. You'll always have something that is remaining. And that remaining thing is called residual. Now, the measure of residual is important to judge how numerically accurate is our solution, which is why we need to monitor the residual. And this residual will never be 0. It will be lower value, and lower the better. So what lower value is the better value? Generally, 10 to the power minus 6 is the value that we go with it. So if the residual is in the order of 10 to the power minus 6, we consider it good enough. So yeah, so how, if you were to plot that residual, initial and final residual, it will behave in this manner. This is the initial residual and this is the final residual. So what is happening here? On the right side, you are seeing a general algorithm to solve a general transient problem. So initially you initialize u, v, p or phi. Phi means any other parameter. It could be temperature, it could be a scalar parameter or anything. So now, so initially you initialize u, v, p. So in the boundary condition file inside u and p, there was internal field in one of the line, if we remember, and that is our initial condition. So initially all the variables in our domain will be initialized to that value. I think you remember it was internal field space uniform 0, 0, 0. If it was velocity, and if it was pressure, there would be only 1, 0 because pressure is a scalar. Here, what we are doing is, before starting the simulation, we are initializing all the variables to 0. So that's what we are doing. So when they put this equation, this value in its internal field value in our equation, you'll get something that is remaining, like some value that is remaining. That value will come as a initial residual. Okay, and now you'll enter to another loop that actually solves your solution in that time step. And while doing that, it will go through a series of iteration. This yellow thing that you are seeing is that series of iteration. And it will finally end. That may end depending on the maximum number of iteration or some residual value that you have provided in your API solution file in OpenFOAM. And when it ends, we will come to a final residual. Now it will move to the next time step. So we are here right now. So it will move to the next time step, and here it will start again. So it will come from here, 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 and it will move to the next time step. Then it will start. So final residual is the residual that is obtained at the final iteration of your internal loop. And we have another loop outside of the internal loop. It is called time loop, which marches you through the time. And here at the beginning of that time step, you'll get another residual, and that is called initial residual. So this is how this thing behaves. And now, so this is how the initial residual behaves, and sometimes it will go to a lower value 10 to the power minus 6 or 10 to the power minus 4, but it always doesn't happen. Whenever it reaches some value or convergence criteria, we say that the convergence is achieved. So we also need to monitor some quantity of our simulation. It could be coefficient of drag, coefficient of lift, or some force. And when you monitor it, in case the residual goes down like this to some lower value, our monitor value will stabilize with the time. And then we say that the convergence is achieved. However, in some cases, in few cases, one example would be an example of flow past a circular cylinder. So whenever air is flowing past a circular cylinder, behind the wake, we have series of vortices, because of which we never have a steady state solution. So in such case, our residual will never reach a lower value. So when we monitor our quantity, that is coefficient of drag or coefficient of lift, we'll get a periodic solution. So it would be something like this. Initially, it will move up or down, and then after some time, you will get this periodic solution that behaves periodic. And when we get this periodic solution, we say that since this problem doesn't have a steady state solution, we'll end our solution here, and this is our solution. So what we learned from here, low residuals do not indicate a correct solution. And similarly, higher residuals do not mean a wrong solution. Even though your residuals are high, you need to monitor your quantity. That quantity is coefficient of lift or drag or any other quantity that you would like to monitor, or your point of interest. Okay, now how is this parameter control in OpenFOAM? So inside OpenFOAM in system file, you'll see FB solution, and inside FB solution, you'll see something like this. So this is for pressure. Similar for pressure, you will have one for velocity, and if you are solving turbulence, then you will have one for K, epsilon, and so on. So here the first one is the solver that is being utilized to solve the discretized equation. And if that solver uses a smoother, then you provide the smoother here. Now, these three are the parameters that controls the residual. This tolerance 1e minus 7, it is the value for the final residual. So whenever that inner loop iteration reaches a final residual value that is less than this, we'll close that iteration and we'll move on to the next time step. And similarly, relative tolerance, it is the ratio of current to the initial residual. And we have max iteration. That is the maximum number of iteration that can be done inside the internal loop. So if any of these three values are satisfied, we'll move on to the next time step. That is what this is saying. And if you want to control the final residual, that is when your actual simulation, whole simulation will end, you'll use something called residual control, and you'll give a value. Here I'm giving 1e minus 6. So whenever the initial residual is below this value, our simulation will end, and it will say that your solution has converged. And here the dot star, it is just a regular expression. It means any value. You can either provide velocity, pressure, or other parameters that you have. But here I'm just giving it dot star, meaning all the parameters. Now let's see how to implement this in OpenFOAM. So I'm going to use VirtualBox. You can use WSL as well. So I'm going to copy one of the tutorials from OpenFOAM directory. So whenever I'm copying, I actually never type the whole command. See, I'm doing $foam_tu. Now, if I press tab, it will automatically complete my command for me. Okay. So now I'm going to do space, and I'm going to type IN. Now, when I press tab, so it is already going to complete it for me. If it doesn't complete it for you, that means somewhere you have made a mistake, your typo mistake while writing the command. Now I'm going to go to PimpleFOAM, and inside PimpleFOAM in the RAS, I'm going to type pits delete, and I'm going to copy this to my current directory or to my run directory, which is from run. So when I press enter, that file has been copied to my $foam run. But now I'm not at $foam run, I'm at my home. So I'm going to go to my run directory by doing this command. And when I do ls, you can see that the pits delete is there. So it has been copied successfully. I hope everyone is with me at this point. Now I'm going to go inside the pits delete. So this is my pits delete case. It has 0, constant, and system. I'm going to do block mesh here. And it has ran. Let's see what's the pits delete case is about. I'm going to do parafoam You can view the mesh similarly, just like how we did yesterday. Create does result.form, and it will create a. You can view the result.form using paraview. So yeah, this is the page Delhi domain. So here we have inlet over here, and our outlet is here, and we have a backward facing step. So this is just a backward facing step. This is our geometry. Now that it's clear, I'm gonna get a file called residuals that will help me to monitor my residuals. Now to do that, I'm gonna use foam get command. You can get any files that you require in your case using this foam get command. Let me show you how it is done. First, I will clear my screen. So FOAM and GET. Now space. Now I'm going to type any files that I require. Right now I require residual file. Okay, residuals. Now if I press enter, it is saying me that it has found two files that has name residuals. One is residuals, another is residuals.cfg. But I only need the first one. I don't need the second one. And it is even suggesting me that choose option 1. So I'm going to press 1 here, and I'm going to press enter. So it is saying that it is copying that file from certain directory that is inside the OpenFOAM 7 to my system. So if I do ls system, you can see that that file is already there. Okay, now let's see what is inside that file. So I'm going to use gedit. You can use notepad.exe if you are following me in WSL. System residuals. I'm going to press enter. So this is my residuals file. As you can see here, I have as include DC. It is just including some file from post processing. And in this field, I am providing the parameters whose residual I want to monitor. In case you are using OpenFOAM 9, 8, here there will be a text saying provide those internal field files here. You just have to remove it and put it like this: fields space bracket p space u and bracket. You just have to write it like that. Now I don't need to save it. It is already saved it, but I'm going to save it anyway. So I'm going to close it. So now that I have a residual file, I also need to include it in my control dict. So I'm going to type gedit system control dict, and I'm going to enlarge this. So in my control dict, I'll go to the very bottom, and I'm going to write functions. And here, I'm going to give a bracket. And here, I'm going to include this line hash include func, and then the file that I have in my system, that is residuals. I'm going to save it. Now, if I can finally run my solver, but before that, I'm going to check the FP solution again. So I'm going to type gedit system and FP capital S solution. So it has opened the FP solution file for me. So this is the file that I was talking about. The line P final. This is for the final iteration. In final iteration, we don't provide relative tolerances to some value. We have to give it to 0. So we have set it to 0 here. And $P means it will just copy whatever we have given here to this place. Okay. Now I'm gonna give it one more line here, max iterate.
What is difference in P and P final?
So P final is so in the final iteration, what we do is we don't want to give any relative tolerances. So P final is just this value, but it is for the final iteration. And what we are doing here is the $P means whatever is here, it will just copy it over here. It is a placeholder. So whatever parameters that we have given here, it will just copy here, and we are again setting the relative tolerances to 0. Okay. So I'm going to give it some value, let's say 10. I hope, let me just check max iter 10. Yeah. Okay. Now at the very bottom inside my pimple dictionary, I'm going to add this line. So let me make this clear. Here in residual control, you provide the value of initial residual on which you want your simulation to end. Okay. So I can do it like this. For you, I can give a value of, let's say, 1 into 10 to the power minus 6. And for P, I can give some value, and then I would have to write for epsilon and for K and for all those. But I don't want to do that. I want to give only one value for all the parameters that I'm solving. So what I'm going to do is I'm going to use this thing called regular expression. So dot star means any variable, all the variable. So you may have all of the above option when choosing the MCQ, right? So it is similar to that. So it is saying all the parameters that I have. Okay. And I'm going to give a value minus 6 for now. Okay. We'll later change this and see what changes that we get. So I'm going to save this thing. Let me just check if everything is correct. Residual control. Yeah. Now I'm going to close this thing. I will clear my screen and I will start my simulation. To start my simulation, I will write PimpleFoam because I'm using PimpleFoam solver now. So it is solving. So while it is solving, let me open a new tab in my terminal. So while it is solving, if I do ls, it has created a new file for me, post-processing, right? So I can go to the, I can, inside this post-processing, let's see what is there. So I have residuals, and inside the post-processing and residuals, I have 0. And inside that 0, I have residual.dat. So this is the dat file where all my residuals in each time step is being stored. Now to view this, I'm going to use the command foam monitor. I'm going to clear my screen. So foam, M-O-N-I-T-O-R. I'm going to press any space and -L. This -L indicates that I want my axis to be logarithmic scale. Okay. Since the residuals are a very less value, it's in the order of 10 to the power minus 6, minus 3. So I will like to use log scale in order to view it. Now I'm going to type post processing and then residuals. Here we have only one file after other file. So if I just press tab, it will complete the command for me. So I'm just pressing tab. I'm not typing anything. And finally, we get to residuals for tab. Then I'm going to press enter. So these are the value of residuals. As you can see, the value is decreasing and our solution is still going on. It hasn't converged yet. The final time step that I have provided is 0.3. So this simulation will run until 0.3, even though the residual value is very high. We can see the value of velocity is 10 to the power minus, the residual value for velocity is 10 to the power minus 4, 10 to the power minus 6. But for pressure, it is still high. It is above 10 to the power minus 3. Sometimes it is coming up and down.
This is initial residual or final residual?
This is initial residual.
Okay.
We are viewing initial residual right now. Now,
can you show control tick file where you have defined that function?
Okay, I'll show that. Don't worry. So our simulation has completed, and even after the simulation has completed, you can see it has not given any text saying that your solution has converged, because in the residual control thing, we have set the value of 10 to the power minus 6, but our pressure value is still high. Now let's force it to converge just to see like what happens when you converge it. Okay. Okay, I'm gonna close this foam, and I'm gonna show you the control dict where I added that function object. So this is how you add the function object. Functions bracket has include func residuals.
Thank you.
Okay, yeah. So now I'm gonna go back to my sixth system and FB solution. Here now instead I'm gonna change it to,
can you please show it again? I'm sorry.
Okay, don't worry, I'm gonna show it again. Here in Pimple, I'm gonna change it back to 10 to the power minus 3. Okay, just do that for now. I'm gonna go back and show that control dict for you. I hope you guys have followed up to here, right? So I'm gonna save it. You just have to change it to 10 to the power minus 3 now. And I'm gonna go back to system, control dict. Okay, this is how you add it. Add the function object. Here, there are different post-processing tool in OpenFOAM. If you want to say find out average of some patch, mean max value of some variable, say temperature, there are different tools available in OpenFOAM. You can add it in similar manner as
So
include
this you have placed for the runtime calculation, right?
Yes,
In the control dict.
Yes.
Okay.
Okay, I hope this is clear. So should I close it now?
Excuse me. Can you tell me what this functions do? I did not understand in the control dict. Like what happens when you are putting it under functions in this curly bracket?
Okay, so this is called function object. And what it does is it will add the residuals file that I just copied into my system directory here, and it will calculate the residuals for me. So when I do this, and then when I run my simulation, it will create this file post-processing, and inside this post-processing file, it will create another file called residuals, where my residuals are stored. Did you get it now?
Yeah, okay, now I understood. Yeah.
Okay. So now
these
residuals
that are stored, these are the final residuals. Like I got a little confused between.
Yeah, this is the initial residuals. We are going to see final residuals at the very end. Hold on to that. These are initial residuals, by the way, if you are having confusion, because in the while checking the convergence of our simulation, we only care about the initial residuals. We don't care about final residuals. Okay. Now let me remove all these directories, this result, because I want to run a new simulation. To do that,
I'm sorry, Avashan. Where should we give the maximum tolerance value for residuals? Like, is it in the FP solution, right?
Yeah, it's in the FB solution. You can just type gedit or notepad.exe if you are using WSL and go to FB solution.
Okay, under Pimple.
Yeah. And in your Pimple, you just have to create this line. You might already have these two lines here.
Kushan, can you give these two files, FE solution and this control dict?
Sorry, you want me to?
Can you put it in the message at this text file?
Okay, text. You want me to copy paste this text, right?
Copy paste in.
Okay.
Was control dict and we need to changes in control dict and FE solution, right?
Yeah.
Okay. Okay,
so
thank
I
you.
pasted the one from control dict. I'm gonna do the same for the control dict as well. Yes, Dhruv, we can see a live plot of residual as well. I'm going to show you. So the last time when we saw the residual, we saw it live only. It's just that I created a new tab, a new terminal, and in that I did the live residual. So I hope everyone has copied those commands. Have they?
could you repeat what is happening when you're putting that line in FE solution?
Okay. So when I put that line in FB solution, this is the value for my initial residual. So when my simulation's initial residual falls below this value, it will say that my simulation has converged. Okay.
Okay.
So I'm going to be quick here. I'm going to use foam this time. Okay, foam clean tutorials. So this will erase all those result from my case. I'm going to do block face again. And I'm going to start my simulation again, pimple foam. So now if I do the same command, here you can see the value of residual. It is live actually. It is being written in the post-processing residual 0 and residual dat, and the foam monitor thing is showing me the residual live. So let's see what is happening here, and at the same time, let's see the videos. So as you can see, the residuals are falling.
Please show that command for residual getting the live.
Yeah. So,
Residual things.
yeah, this is the command for that. I'm going to type this command in the chat. Anyway, we are running out of time. So what happens is that when you do that, delete system FV solution. When you do this, when my residual reaches less than the value of 10 to the power minus 3, my simulation will end and it will show that pimple foam has converged. This is what happens and how you control your residual value. So if you guys have any problem while following this tutorial, you will be provided with the videos later on. You can just write to us. We have our next session that will be on turbulence. So I would like Professor Raghavendra to start.
Yes, thanks a lot, Abhushan.